Hello, Mathies. Welcome back. In our last video, we looked at the parameters of A in vertex form. In this video, we're going to look at the parameters of Q and P. So let's start with Q. I'm going to go back to that investigation and show you the effects of Q. There we are. Okay, so Q is the value that's added on the end. So this is my base parabola. Now you might be wondering why the parameters on the side say H and K instead of P and Q. The reason is in 30-1 we use H and K because those are the parameters for translations in general for every function. But because quadratics are so important, they have their own variables called P and Q, but the effects are still the same. So the K value is the same as the Q value on the outside. So let's look at what happens when I add a number on the end. So right now I'm adding on nothing, 0. So as I add on a number on the end, what happens? Looks like I'm moving up. Let's go back down. So I'm moving up. And how much I'm moving up depends on the value. So notice when Q is 4, the Y value is 4. If I put the value to be 6, it's off the graph there, but you can see the Y value is 6. So it looks like that Q value is the Y value as I go up. X is staying the same, so it's not affecting my X value. Now, if a positive number goes up, a negative number probably goes down. Let's just double check. Yes, and it does go down. So it's like I'm picking the graph up and I'm moving it up K units if it's positive, or sorry, Q units, or I'm moving it down Q units if it's negative. So this is a vertical translation. So if Q is positive, we saw the graph moved up. If Q is negative, we see the graph moves down. So here's the mapping notation. Remember, those are the instructions on how to go from point to point, where this is just a point on your base graph. So if I take a point on my base graph and I do a vertical translation, that's only affecting my Y value. So notice X stays the same and Q is just added to Y. And that's because Y points are vertical points. They go up and down. So Q would affect that and it would make it go up or down. So let's predict how each graph would look. If I have x squared plus 4, so that's my base graph of x squared, and then I'm adding 4 to it. So what I should expect to see is a vertical translation up 4 units. So let's put that on our graph. So normally my parabola starts at 0, 0. Now the number in front of x squared, since there's not 1, is 1. So that just means I go over 1 and up 1, over 1 and up 1. So let me just remove my trace points there. So what I'm doing is I'm really taking these points here, if they'll let me take them, and I'm going to move them all up 4 units. So I'm going to take this point, and the other point, and I'm just going to move them up 4 units. So let's look. I'm going to go up 1, 2, 3, and 4. So that's what my graph should look like if I've done it correctly. Okay, let's look at my next one. So my next one is y equals x squared minus 3. So again, notice there's a 1 in front there. Okay, so we're doing x squared minus 3. So remember when we had negatives, those numbers were moving down. So this is actually a vertical translation down 3 units. So let me just do this in a different color here. So normally I would start here, and remember I'd move over 1 and up 1, over 1 and up 1. And now what I'm going to do is take these points here, and I'm going to move them down 3 units. So I'm going to go down 1, 2, 3. So it's literally like picking the graph up and moving it over yourself. Okay, so let's see how close I was. So look at this graph here, x squared plus 4. Ooh, looks pretty good. It did in fact go up 4 units. And then let's look at x squared minus 3. And there we go. So it looks like it works. Now, you might be thinking that that red graph looks wider. And I'm going to tell you that the wideness or narrowness of the graph, did I just make up a word? I don't know. Wideness, narrowness? How wide or how narrow a graph is tied to your A value. So the reason that the red graph, when I went down 3, looks wider is just because I'm seeing more of the graph. So don't let that trick you. Okay, now I want to look at the value inside the brackets, my p-value. So let's go over and look at our p-values for that one. So I'll go back over here and I'll put this one here back to 0. There we are. So there's my base graph. So we're looking at the p-value, but again, they call it an h-value, okay, but it means the same thing. It's inside the bracket. So we've had A that opens up or down, makes the graph wide or narrow. We've had our Q value, which moved the graph up and down. The only thing left that we have to do is move the graph left and right. So let's look at what happens when our p-value is positive. So if I make my p-value positive, I go over in this direction. I go to the right. So notice I have a value of 6. Look at my x-coordinate. It's 6. Now let's look at if we go back to the center here at 0. If I make it negative, it's going to the left. So positive takes my graph to the right, negative takes my graph to the left. So let's put that together. Now, this is a horizontal translation because I'm moving left and right. So I saw when P was positive, the graph moved to the right. When P was negative, the graph moved to the left. Now this gets a little bit tricky when we put it into the function because our function, and remember we're building towards this function here. We're looking at y equals a times x minus p squared plus my q value. So notice that a is just straight a, q is you're adding on q, but p is a little bit different because it's a minus p. So if we put a positive into this format here, x minus a positive is just x minus p. So the p-value that we put in was positive, moving the graph to the right, but look at how it appears in the equation. It appears that p is negative. If p is a negative value, we know that the graph moves to the left, but look what happens when we put a negative in here. If I subtract a negative, it becomes a positive. So it appears a little bit counterintuitive to what we think, and I assure you that is because the base function is x minus p. So here's my tip for you, okay? When you look at this, I want you to remember that horizontal lies. So x minus p means I'm actually going to the right p. X plus p means I'm actually going to the left p. So remember that horizontal lies. Now I hope you hear the double entendre there. Horizontal lies. So get it? It lies down, but it also lies because it's not telling the truth. So that's how I want you to remember it. Horizontal lies. So let's use this and predict how each graph looks, remembering that horizontal lies. So look inside the brackets here. I have a +4. So I would think it goes 4 to the right, but actually horizontal lies, it goes 4 to the left. So looking at my base graph, so remember I have my origin, I have 1 point on either side. Since I'm dealing with a horizontal translation, just like a vertical translation, I can pick the whole graph up and move it over. So I'm going to move it over 1, 2, 3, 4 times to the left. There it is. Okay, let's look at our next graph. So in our next graph, we'll look at x minus 3. Now, since it's a minus 3, remembering that horizontal lies, it's actually not going to the left, it's going to the right. So let's look at our base points here, here, and here. And then remember that these points here are going to be all moved to the right 3 units. So I can just go 1, 2, and 3. Okay, so let's see if I did a good job there. So x plus 4 squared, yes, in fact, moves to the left 4. And then x minus 3 squared does, in fact, move 3 to the right. Okay, so it looks like that works. So what I want to do is put this all together for you. So putting this all together, and we're going to focus on this more in the part 2 video for 3.2. The vertex form of a quadratic is a times x minus p squared plus q, where p and q are the vertex. That is super important that you guys catch on to this, because if I'm moving something left or right, up or down, that's affecting my vertex. So in terms of the equation, here's how I want you guys to remember this, okay? So on the outside, the A and the Q values, the outside, that kind of forms a Y, that affects the Y values only. So A and Q on the outside are your vertical values, your vertical stretches, reflections, and translations. And I want you to remember that vertical is straight up. Not only is it straight up vertical, it also tells the truth. So it's exactly as you would think. On the inside, we have our P value. Now, P is inside and it's attached to my X. It is a horizontal value, and horizontal values only affect X. But remember, horizontal lies. So it lies as then it goes left to right, but also lies as in doesn't tell the truth. Now, I do have an optional video for you guys in your notes, and this is actually a video that I made for 30-1, but it would be useful for you as well. If you want to have that question answered, why does Q, if it's positive, go up or down? Why does P, if it's in the formula, minus, go to the right and positive go to the left? I do a more in-depth explanation of that. So if you kind of like to know the theory behind it and why every parameter works the way it does, this video would be worth a look for you. So let's do an example where we're actually putting it all together. So let's describe the transformation. When you guys describe the transformation, I want you to use all the proper notation. So start with the ones on the outside. So if I look at the one on the outside here, I have a 1/3. First thing I notice is it's positive, so I know it opens up. Second thing is I notice that it is 1/3. So it's going to be a vertical kind of stretch. So starting at 0, I know that it would go over 1 and up about 1/3. Over 1 and up about 1/3, like that. Okay, then I'm going to move to the inside here. This -3 tells me I'm actually going 3 units to the horizontal lies to the right. So I can take all these points and move them over. 1, 2, and 3. Okay, and then on the outside, this -4 tells me that I have vertical translation down 4 units. So I'm going to take all these points and move them down 4 units. So I'm going to go 1, 2, 3, and 4. So that should be the basis of my points. But here's how I want you to put it all together in my description. Vertical stretch by a factor of 1/3. That makes the graph wider. Horizontal translation, 3 units right. Vertical translation, 4 units down. Okay, so looking at what I did, I can clearly see where my vertex is. So I can see it graphically, but I can also see it if I go back to my equation here. Okay, so P I can see is +3 because horizontal lies, and Q value is -4. So that is what my vertex looks like. So remember, vertex is your P and Q. Now the P value tells you when the max or min happens. The Q value tells you what the max or min is. Okay, axis of symmetry, remember that is that vertical line that passes through the x coordinate of the vertex. So it would be something like this. It's the line that splits it into symmetrical halves, and I'll just label that as 3. Max or min, I know this graph opens up, so it has a minimum, and that minimum is at y equal to -4. Now, the minimum occurs when, that means x, when x equals +3. So remember the domain for every single parabola, that white glove notation, the set of all x such that x is an element of the reals. The range, since I have a minimum, is the set of all y such that y is greater than or equal to -4. Okay, so let's put this all together and see if I did a good job starting my sketch. I obviously have to finish it. So putting it there. Not bad. My A points are a little bit off, but that's good. That's a good graph. Okay. I want you to remember that there are arrows on the end here. They do extend infinitely in both directions. That's why I have x is an element of the reals, because I cover all of the x values. Okay. So remember all of my tips. Horizontal lies, vertical is straight up, and remember my tip for my A value. You can remember that negative parabolas go down because negative people tend to frown. Okay, so you guys can move on and do the practice questions in my notes, and then of course move on to your textbook questions. I hope this video helped, and I look forward to seeing you for the next one for 3.1.